Objective number 4. Solve exponential equation. We will use the property for solving exponential equation. If we have a to the u equal to a to the v, in this case a is the base and a are the number, then the exponent u and the exponent v must equal each other because they are having the same base. In example number 5, we want to solve for the x, and on the left hand side we have 2x minus 3. On the other side we have 32. If you write 32 exponent 1, then we have left hand side and right hand side do not have the same base. We need to make the same base. That means 8 and 8. So we can see that 2 is the simplest number already. So we're going to keep. And then 32, we know that 32 is 2 to the 5th. Now the same base, 2 and 2 for left hand side and right hand side, then we will equal the exponent. So x minus 3 equal 5. We add 3 both sides, then x equal to 8. This is the solving equation, so we can check. We have 2, 8 minus 3 equal 32. So 2 to the 5th power equal 32. We got the true statement. So the solution set is 8. In example number 6, we will copy the same style like example number 5. That means we need to make the same base for both of them. In part A, we can see that 32, we cannot write 4 to the power something. So we have the left hand side 4, but the right hand side, there's no way for us to make 4 to the power something. So we're gonna have to move the 4 a little bit down. So we're gonna write 2 square for 4, and then the exponent x squared is outside. And we have 2 to the 5th for 32. We did that before. So we're gonna use the power rule. The power rule, we have a to the n and then to the m. Then we will multiply the n and the m together. So 2 and then 2x squared, because 2 times x squared is 2x squared. Then you can equal the exponent 2x squared and the 5. Now we solve, so we get x squared equal 5 over 2, and then x equal plus minus square root of 5 over square root of 2. We want to rationalize the denominator, so we get square root of 10 over 2. We will check the answer. Now we will plug x equal plus minus square root of 10 over 2 into the original problem. I'm going to put both of them at the same time. So plus minus square root of 10 over 2 square equal 32. Now we have 4 plus minus square root with square will become positive anyway. So on the top we will have 10, because square root of 10 square is 10, and then in the bottom is 4. So 5 over 2 equal 32. In this case, we will use the calculator. If you want, you can do 5 divided by 2 is 2.5. We can check the calculator and the answer is correct, so it's true. The other way we can do this is that we can do 4, the exponent is 5 and the index is 2. So square root of 4 is 2 and 2 to the 5th power is 32. then you don't have to use calculator. Okay. Now problem B, we see that one side, in the right hand side we have E already. Now the left hand side we have E, but we have two of them, so let's make one. Okay, we use the quotient rule. The quotient rule is that if we have a to the n divided by a to the m, then we will subtract the exponent. So we have e, and then the exponent we will subtract, so x squared minus 2x. On the other side we get e to the 8. Now we will equal the exponent together. This is the quadratic equation, so we will minus 8 both sides to make 0, and then factor. So we're going to have 4 and 2, so minus 4 plus 2. So x equal to 4 and x equal negative 2. We will check the answer for both of them. So I will check x equal to negative 2, then e, negative 2 squared is 4, divided by e, 2 times negative 2 is negative 4, and e to the 8. We will subtract, so 4 minus negative 4 is equal to e to the 8, and both sides are the same because 4 minus negative 4 is 8. So x equal to negative 2 works. Now we check x equal to 4. We have e 4 squared is 16, and e in the bottom we have 2 times x, so 2 times 4 is 8. And then we subtract, then we got e to the 8 equal e to the 8. Then x equal to 4 is also the answer.